first midterm exam will be 5 questions. If you have a chance to print this exam and solve it, that will be fantastic. If you don't have, okay, go ahead and prepare few paper and start to solve question number 1. Go ahead, question number 2. Go ahead and then to the question number 5. First question. We have cylinder with weight 1000 Newton. So if the weight of cylinder C is 1000 Newton, we would like to determine what is the weight of cylinder A and what is the force in member or rod or cable DE, just acrobium. This system is in acrobium. But I'm gonna add something here. I will add something here. We have something, we don't have a regular or common type of rod DE. No, we have something here called spring. We have a spring, and for any spring we have something called stiffness K, for example equal 500 Newton per meter. Keep it in your mind just for a few minutes and I will discuss it later. We have a spring, I don't care. We have a spring or not, I don't care. We have a pulley, this is pulley at B. So any force here, which is 1000 Newton, will be the same force in this rod like this, 1000 Newton. That means for particle or hook E, we will have a force here, 1000 Newton. I'm talking about this rod. From the side of the pulley, we have 1000. From the other side in the same rod, we will have the same value in opposite direction, 1000. And we understand this. The first step or the first hint or the first trick in this problem, we have pulley. So that means this force will be the same like this one, will be the same like this one. And we have vertical weight, which is cylinder A. This weight is unknown. And we have a spring here. Actually, I don't care about any spring or rod. I don't care. We have another force here. This force called FED. So if you have a spring in your problem, it's not a big deal. It's a force. So ED is a spring. I don't care. It's a force. ED. So we have particle E in acrobium. Do you remember if you have forces in 2D in acrobium, what should I do? We have two equations. Summation of all forces in X direction equals 0. Summation of all forces in Y direction equals 0. You are done. You are done. This force is given. We have here the angle for this force, 30. So if you apply summation f of x equals 0, I believe in X direction, we will have 1000 cosine 30 minus FAD equals 0. We have only one unknown, FAD. So I can figure out the value of FAD. It will be 1000 times cosine 30. It will be 866 Newton. if you apply summation f of y equals 0, any forces in y direction, we will have 1000 sine 30 up minus w down equal 0. Hey guys, 1000, if you would like to make more details, 1000 in x direction will be 1000 cosine 30. In y direction will be 1000 sine 30. And this force in x and this force in y. That's it. So the only unknown in this equation will be w. So I can figure out the value of w will be 1000 time sine 30. It will be 500. So the required weight at A, it will be 500 Newton. And the force in this spring, how much? 866, which is FAD. Guys, any questions so far? Any questions so far? So don't be surprised. We have spring. We don't care. Spring or rope or something else, it's a force. Any questions so far? Okay. But we have another part. What is in this problem? What is the elongation in this spring? You know, if you have a spring and you apply a force, this force will elongate this spring by delta. So how can I figure out the elongation in any spring? It's very easy. The given stiffness, K is a stiffness. What is the meaning of this stiffness? It's 500 Newton per meter. That means if you have a force 500 Newton in this spring will be elongated 1 meter. The meaning of stiffness of the spring, K, 500 Newton per meter, which is given, the meaning is we need 500 Newton on this spring to make elongation 1 meter. Anybody can remind me what is the force in this spring right now? Based on your calculation, the force in this spring equal 866. So the force right now, 866 Newton. Can you tell me what will be the elongation? So the elongation will be 866 times 1, this one times this one, divide 500. So I can figure out the value of delta will be 866 divide 500. It will be 1.73 meter. Anybody has any question related to this point? So if you have a spring, your calculations will be the same. Nothing will be changed. Remove your spring and put regular force. Go ahead and apply your equilibrium equation and get your unknowns. Once you get your unknowns, we have another part in this problem. We are looking for what is the elongation in this spring. Okay, so go ahead and figure out or search for what is the stiffness. It's given 500 Newton per meter. That means we need 500 Newton to make 1 meter stretch. But the actual force in this spring based in your calculations, 866. So if you have a force 866, what will be the elongation? So you can do some calculations. 866 times 1, divide this number, so I can figure out the value of elongation or delta. One more time. One more time. Okay. Guys, the K, which called stiffness, 500 Newton per meter is a given. So if you have another problem, probably you will have another value for K. So K is given. Whatever the value, 500, 1000, 200, 100, it's a given data. That means 500 Newton, we need 500 Newton to make 1 meter. The meaning of stiffness means 500 Newton per meter. That means we need 500 to make 1 meter stretch or elongation. Based on your calculations, the force in this spring, how much? What is the force in this spring? How much? 866 Newton. What will be the elongation, delta, under the effect of this force? Can you multiply your diagonals, this one times this one, equal this one times this one? So 866 times 1 equal 500 times delta. That means your delta in one side will be 866 times 1 divide 500. So I can figure out the value of delta, which called elongation in the spring. Do you still have more question? Mitchell, Serena. Spring is a given data, so based on the given in the problem. Okay, perfect. Perfect. Any more question? So guys, it's a very, very simple problem. But I need only don't be surprised if you have a spring. If you have a spring, nothing will change in your equilibrium equations. Everything's the same. But we have a new part in the problem, probably. We'll ask you what will be the elongation in this spring. So go ahead and search in the problem. What is the value of K? K will be given. 500, for example, 500 Newton per meter. That means we need 500 to make 1 meter. This is the meaning of this expression. 500 Newton per meter. That means I need 500 Newton to make 1 meter elongation. What is the actual force? Based on your calculation, it was 866. That means this force will make how much elongation? Your diagonals, multiply your diagonals. So 500 times delta equal 866 times 1. And set up this equation. From this equation, you can figure out the value of delta. It's very simple. It's very simple. Okay? Okay. Second question. We have a system of forces, F1, F2, F3. And looks like F2 is unknown. And the angle theta is unknown. The resultant force is given. We need to figure out what is the value of F2 and the theta. We don't care. We don't care what is the required. We have steps. First step, like we did here, first step, we need to break each force to two components. Let's start with F1. Do you think F1 in X direction, how much? F1 in Y direction, how much? F1 is given in X direction 80. So we have positive 80 in X. We don't have Y direction. What else? F2. What is the X direction for F2? What is the Y direction for F2? Guys, remember, your angle must be within X or Y. So F2 with X direction, what is the angle? Don't say theta. Don't say 25. No. The angle between F2 and the x-axis is 25 plus theta. So your x component will be F2 cosine 25 plus theta. Your y direction will be negative F2 sine 25 plus theta. Do you agree? I think so. You should agree with me. Okay, that makes sense. What else? For F3, what is the x component for F3? What is the y component for F3? F3, we don't have angle, but we have right angle triangle. So if you select your angle is here, so we will have F3, which is 52 cosine theta and 52 sine theta. Go ahead and put your triangle here. I think this angle will equal to this one. So your angle theta will be here. This one is 12. This one is 5. This one is 13. That's right, yeah. So this value will be 52. What is the value of cosine? Cosine will be 5 divide 13. 52, what will be the sine value? Will be 12 divide 13. So I can figure out this value. 52 times 5 divide 13. It will be 20. This one will be 52 times 12 divide 13. It will be 48. Do you have any more forces? I'm talking about forces. I'm not talking about resultant force. Forces. We have 3 forces only. F1, F2, and F3. We are done with all of them. So go ahead and search for the resultant force. What do you have about resultant force? So please go ahead and read your problem carefully. The resultant force is directed along the positive U axis. We have axis here. I don't care about this axis. For F2 or F1 or F3, we don't care. Our concern is X direction and Y direction. But for the resultant force, we have a resultant force here in this direction for U. Here is the R. The value of this R equal 50. So we have a value here called R equal 50 in the same direction of U. Actually, I don't care. We have X and we have Y. Can you tell me what is the angle for R? What is the angle of this resultant? Someone will say, hey, it's not given in the problem. No, it's given. The problem says R in the same direction of U. And U with angle 25 with X. That means R will be with angle 25. So I can get the X component for R, which will be 50 cosine 25. I can get the Y direction of R. Please don't forget your sign, because Y direction will be negative. 50 sine 25. So your final answer will be 50 times cosine 25. It will be 45.3. 50 times sine 25. It will be negative 21.1. Any questions so far? Guys, any questions so far? Yeah, thank you. We are done. We are done? Yeah, we are done. How? X component for F1 plus X component for F2 plus X component for F3, X component plus X component plus X component for the forces equal X component for the resultant. Then Y component for F1 plus Y component for F2 plus Y component for F3 equal Y component for the resultant. Guys, if you have forces and you have resultant force, that means summation of all X component for these forces equal X component of this resultant. Summation of all Y components of these forces equal Y component of this resultant. I believe I can solve these two equations together to figure out what is the value of F2, what is the value of angle theta. The problem is looking for what is the value of theta, what is the value of F2. Any question? Looks good. And if you go back to your homework, probably your quiz, I believe, you will find something like this. Third one. Yeah, you have to solve to get F2 and theta. Two equations only. So you can solve for F2 and theta. So try. Question number 3. Guys, here you have to solve to find what is the value of theta, what is the value of F2. If you didn't get the final answer, you will get probably 1 point or 2 point deduction. So you have to solve because there are only two equations. Okay. Anyway, your quiz. Do you remember your quiz? I believe last week. We have many forces. Guys, we have many forces. We have F1. How much? 200. Guys, you need to read your problem and read your figure. You have to put your data on the figure to be familiar with everything. We have F2. How much? F2. How much? 300. We have F3. How much? 400. What about this force? 225. It's F4. What about this force? It's F5. So how many forces do you have? We have 5 forces. We have 5 forces. We are looking for what is the magnitude and the direction of the resultant force. It's a 3D problem. How did you know it's a 3D? Because we have 3 axes. Here is x-axis, here is y-axis, here is v-axis. So we have 3 axes. So this force is in 3D. So go ahead and break each force to 3 components. Let's start with F1. What do you think about F1? I think we have 3 angles. Alpha, beta, gamma are given. Do you remember if one of them is missed, what should I do? Do you remember? I just remind you. We have expression cosine square alpha plus cosine square beta plus cosine square gamma equal 1. This equation will help you to figure out the missed angle if you have, but in this case we don't have. So F1 as a vector will be 200 cosine 60 I plus 200 cosine 60 J plus 200 cosine 135 K. What else? F2. What do you have about F2? Wow, F2 in Z direction. So F2 as a vector will be 0i, 0j, and positive 300k. What else? F3. What do you know about F3? Guys, I would like to remind you for something very important, and I would like to record it inside my video. I can figure out who is working or who is solving with my notes or my method in solution, and who is cheating from another source. You know, I can figure it out. And also during the exam, you don't have time. You don't have any time even to check your cell phone. If you are trying to only check your cell phone, you will lose more time and you will miss the due date. And if you miss the due date, you will lose 20 points. So please, once you receive your exam, put your head in the exam, your pencil or your pen in your hand, your calculator. Don't try to pay attention to anything else. For F3, this F3 in negative y. So F3 as a vector will be 0i, negative 400j, and 0k. Yeah, thank you. What about F4? Please don't forget any. For F4, where is F4? Here you go. This is F4. In negative x. So F4 as a vector will be negative 225i, 0j, and 0k. For F5, what do you have for F5 as a vector? So F5, wow. So F5, we have something called projection line. Do you remember that? Let's do it here for you. For F5, for this projection line, I will have 150 cosine 45. And I will have in Z 150 sine 45. This projection line will be divided with x by cosine 30. So we will have 150 cosine 45 cosine 30. And here the negative y direction will be 150 cosine 45 sine 30. So your components for F5 will be in x positive 150 cosine 45 cosine 30. In x will be negative, don't forget any sign, 150 cosine 45 sine 30. In z will be positive 150 sine 45k. Do you have any more forces? No, we are done. We are done. X component for the resultant, Y component for the resultant, Z component for the resultant force will be X component summation of all X component. Please go ahead, add this X component plus this one component plus this one plus this one plus this one all x components to get the x component of the resultant. If you are looking for y component, summation of all y component of the forces. So go back, y component plus y component plus y component plus y component plus y component. I can figure out the y component. What is the value of z component? Summation of all z components for the forces. This one plus this one plus this one plus this one plus this one, you can get a number. So we have three numbers right now. So your resultant as a vector will be this value I, this value j, this value k. If you are looking for alpha, beta, gamma, inverse cosine, this component, which is x, divide r. Inverse y component, divide r. Inverse cosine z component, divide r. By the way, your r value will be square root for rx squared plus ry squared plus rv squared. So once you get x component for r, y component for r, z component of r, I can figure out what is the value of r as a one value, and I can figure out the angle alpha, beta, and gamma. For F5, we have something called projection line. We have something called projection line. Where is the projection line? Here you go. This one. The angle 45 degree is given between 150 and this projection line. So this projection line will be 150 cosine 45. Why cosine? Because this projection line adjacent to this angle. Then the y component will be sine. So first step, you need to break 150 between projection line and z component. Then, second step, you need to break this projection line between x and y using another angle here, which is 30. This 30 given between projection line and x. So your x will be cosine. Remember, this value 150 cosine 45 is this value. So this value multiplied by cosine, and this value 150 cosine 45 will be multiplied by sine 30. So finally, you can get the three component for x and y and z. And don't forget the sign. For x is positive, for y is negative, and for z is positive. If you go back to week number 4, module number 4, you will find all of these cases. Do you remember? Anyway, this problem. Most of you in the homework were cheating this problem from another source. And you lost probably 3 points or more in the exam. And you will find me making a circle around your solution. Guys, I can figure out who is cheating from another source, who is trying to solve the homework from another source. And be careful. Probably I will give you the problem. You will find the same problem in another source, another textbook, another solution manual, but be careful, the numbers will be different. Like last quiz, yesterday or Monday, I give you a hint, a trick. This problem that I gave it to you, do you remember your quiz on Monday? This problem is the same problem in a textbook or solution manual, but I changed the number. This distance is 50. In the textbook, it was 20. Most of you still using 20. I don't know how you get this 20. That means you opened another resource. You are trying to solve the quiz from another resource. That means you are cheating. So if you decide to cheat, be smart. If you decide to cheat, please be smart. Probably I will give you points for your smart skills. Anyway, guys, if you have problem like this, we have a vertical force here, which is fish. How much? It's 400 Newton. And we will have a force here, and we have force, and we have a third force. We have three axes, X and Y and Z. Guys, I don't have a choice for these axes. These axes are constant. I have to respect them. So this axis and this axis and this one are intersects at this origin. So we need to figure out what is the coordinate of point A, what is the coordinate of point B, what are the coordinates for point C and point D. Where is point A? Here is point A. Coordinate of point A in X will be 2. In Y will be 0. In Z will be 0. Coordinate of point B, where is B? Here you go. Here is B. So in X, it will be 0. In Y, it will be 4. In Z, it will be 4. Point C in X will be -2. In Y, 0. In Z, 0. Point D, which is at the back, in X, 0. In Y, 0. And I'm sorry, in Y, not 0. In Y will be -5.6. And Z will be 0. So first step to solve this problem, if you go back to my notes, if you go back to my recorded videos, you will find the first step is figuring out what are the coordinates of each point in your problem. Second step, let's start. We have vertical force here, 400. So the weight as a vector will be 0x, 0y, and the -400 T. Let's do the first force, FBA. Do you remember FBA as a vector? How can we figure it out? FBA will be FBA as a value time BA. So point A minus point B. BA, so the second point minus the first point. So A minus B. So 2 minus 0 will be 2I. 0 minus 4 will be minus 4J. 4 minus 4, I'm sorry, 0 minus 4 will be -4K. Divide these numbers under square root, these numbers square. 2 square plus 4 square plus 4 square. So I can figure out FBA as a final value will be, I can figure this number, how much? 4 plus 16 plus 16, 36. So this number will be 6. So your final will be 1/3 I, -2/3 J, -2/3 K. So finally, if you would like to simplify it more, so it will be 1/3 FBA I, -2/3 FBA J, -2/3 FBA K. What you did with FBA, we will repeat it for FBD, for example. So FBD, it will be as a vector, it will be FBD as a value, time. Point D minus A, D minus B, B, D, so D minus B. And finally, I will do the same for FBC, equal FBC time. So how many forces do you have? We have 1, 2, 3, and 4. And each force has 3 components, X, Y, and Z. X, Y, and Z. And this one also will be X, Y, and Z. And this one will be X, Y, and Z. All of these forces are in equilibrium. If you have forces in equilibrium in 3D, summation of all X component will be 0. Summation of all Y component equals 0. Summation of all Z component equals 0. So you can set up 3 equations in 3 unknowns. So I can solve them together to figure out the value of FBA, the value of FBC, the value of FBD. Guys, can you watch my format in solution? If you look back to your homework, you will find big difference. You will find big difference. Last problem, just reaction. Here is the original problem. This problem, guys, as first step, we have 2 reactions here, YA and XA. We have 1 reaction here is YB. First step, after you put your reaction, this distributed load, we have to figure out the equivalent value. Do you remember what was the value? How can we figure out the equivalent value for distributed load? Multiply this value by this distance. So 50 times 20, it will be 1000. Guys, do you remember where this equivalent force, it will be from this side, how long? It will be 10 feet. And from the other side, it will be 10 feet. Then we have 3 equilibrium equations, summation f of x equals 0. So xa will be 0. Summation f of y equals 0. Guys, for summation f of y, I'm talking about forces in y. So we have positive YA, we have negative 1000, we have positive YA. My question is, do you think 200 is a force? I need answer. Do you think 200 is a force? No. 200, it's not a force, it's a moment. So this equation related to forces. So I cannot include 200 within this equation. Equals 0. Third equilibrium equation, summation moment. I'm going to choose A equals 0. Assume this direction is positive. So we have 1000 because YA and X will be cancelled. We have 1000 times 10. 1000 times 10. We have negative YB times 20. We have positive 200. Anybody can tell me what is the distance for 200? What is the distance between this moment and your point A? Do you remember what is the distance? The same names, the same name who are responding to me. Nobody else. We don't have distance. We don't need distance because 200 is a moment. does not need distance to be a moment because it's already a moment. So we don't have to add distance here. The only unknown will be yb. I can figure out the value of yb. I can go back here and figure out the value of ya.